Hi calculus students, this is Lakshmi and Ala'a here, and we're going to be giving you a tutorial on lesson 1.5 infinite limits. So let's get started. Graphing is a very important part to infinite limits, so I'm going to go ahead and start with getting my axis up here. And just to explain the general concepts, I'm going to be using the graph y equals 1 over x minus 2. So you guys can pause it right here and graph this in your notebook if you want, or if you guys want, you can just stay along with me and I'll graph it for you. So easily you can just pick some points and graph it if you want. So let's get this graph going. Oh, getting kind of close. Okay, basically what we're looking for in infinite limits is we're looking for an x value where the graph either goes to negative or positive infinity. Can you guys tell me what x value that it is on here? If you guessed x equals 2, you're correct, because as you can see from the left side, it's going to negative infinity, and from the right side, it's going to positive infinity as the graph approaches x equals 2. That means you can write two limits from this graph. You can say the limit, which I'll denote by LT, as x approaches 2 from the right, which is 2 plus of 1 over x minus 2 equals positive infinity, and the limit as x approaches to negative, which is just basically approaching 2 from the right, of 1 over x minus 2 would equal negative infinity. Okay. And that you can see very easily graphing. So if you ever get confused with infinite limits, always graph it either by hand or on your calculator. It's sure to help. But a lot of the times when we work with infinite limits, we are often looking for this value right here, where on our graph is x equals 2, where the graph approaches positive or negative infinity, but never actually touches x equals 2. It always gets closer and closer, but never quite there. How we find this, or more importantly, what is this called, I'll give over to Ala'a to explain.
This line is called a vertical asymptote, and you can find it either by graph, how she showed you already, or you can find it by solving the equation of y equals 1 over x minus 2. The way you wouldn't exactly solve the whole problem, but you would just find the denominator, find where it equals 0. Where it equals 0 would be x equals 2. If you put in 2 into this equation, then you will find that it will be 1 over 2 minus 2, which is 1 over 0, and that is undefined. So that way you draw the line at x equals 2, signifying that that line does not exist. Now we are going to be doing an example problem to see if you understand this. Now for these examples, we're going to have two of them. You don't have to, you can pause the video and watch it later to make sure that you understand how to do these problems, or you can follow along. The first problem is y equals 1 over 3x plus 4. Now the only thing we're going to do is we're going to figure out where there's a vertical asymptote. The way you do it, again, is you set the denominator equal to 0 and you solve. This is just basic algebra. You just subtract 4 and then you divide by 3 and you get x equals negative 4/3. So you can say your vertical asymptote is at x equals negative 4/3. Now for the second problem, it's a little more complicated, but not too much. The second problem is y equals x squared plus 6x plus 8 over x squared plus 4x plus 4. Now, you know, to start every problem, you have to factor out. And the way you do it for this one, you just do the denominator because you're only finding the vertical asymptote. So you set it equal to 0, and then you simplify it the most you can, which would be x plus 2 squared, and you set that equal to 0, and then you solve, and you can get the vertical asymptote is x equals -2.
Okay, Bardell's class, next up we're going to do some examples of actually trying to find limit problems, since this is an infinite limit section. Okay, so let's use a different example from the one we had before. Let's say the problem says the limit as x approaches 3 from the right, so with a plus, of 1 over x minus 3. Okay, there are two ways we can do this. The first way is graphically, like we did before, where we actually get our axes, and then we mark them. We find our asymptote by setting it equal to 0, so it's at 3, so this would be our asymptote. And then we draw our graph. And we can see from the right, as x approaches 3 right here, it goes to positive infinity. So this equals positive infinity. But who likes the graph? I didn't like the graph as a calculus kid. So there is another shortcut way to kind of do this. Since we're looking from 3, so since we know that it's going to be either positive or negative infinity, we just have to figure out the sign. How we can do this is say, let's take this example. We're looking from 3 to the right. So what's a number right of 3? Or say one more than 3, we can use 4. What you do is you plug 4 into 1 over x minus 3. So we could say 1 over 4 minus 3, which will give you which gives you 1 over 1, which is positive. So you know it would be positive infinity. If this number, when we plugged it in, and it equaled, say, a negative number, then the answer would be negative infinity. Okay, so I'll ask some more examples of this for you guys, so I'll give it over to her.
Alright, so for these examples, you will try to solve the limits you can try on your own, or you can follow along with us. So the first problem would be the limit as x approaches 3/2 of 1 over 4x minus 6. Now you notice for these, it doesn't have a positive or a negative. So you have to find the right limit and the left limit. When you find the right and the left limit, they both have to be approaching the same number for the limit to exist. So first let's find the right limit. For the right limit, if you remember, you have to use a number that comes on the right side of the number they have that is approaching. For example, the limit is approaching 3/2, so you can just add 1 to that, and you will get 5/2. And so you plug that into x, and you will get a positive number. It doesn't really matter it does really matter what the number is, because, oh my god, no, this is not working.
What all is trying to say is, yes, it kind of matters what the number is, but we're basically only trying to solve this to figure out whether it's a positive number or a negative number. So in this case, this would be a positive number. So what would the answer be? That's right, positive infinity. Okay, let's take it to the next one.
Okay, so for the next one, you'll find the limit as x approaches 3/2 from the left. For this, you can use a negative number. It's easiest to just use a negative whole number, so just use -2. So you plug in -2 to x, and you'll get -1 over 14, which doesn't really matter because, again, it's just a negative number. You'll get a negative number. And because you got a negative number, the limit would be in negative infinity. So now you notice the right limit is infinity and the left limit is negative infinity, and those two numbers are not equal, that means that the limit does not exist. And that's very important because the limit has to be approaching the same number on both sides for it to exist.
But most of the time when you get practice problems, say in the textbook or even on tests, they are specifically going to ask for either the right limit or the left limit. So if they ask for the whole limit, keep this in mind. But usually at most of the time they're going to ask either specifically for a right or a left limit.
So let's do one with just the right limit. Our next example would be the limit as x approaches 1/2 from the right of 1 over 2x minus 1 cubed. So again, you choose a number that's to the right of 1/2. For example, the easiest number you would choose would be like 1. So plug in 1 to x and you will get 1 over 2 minus 1 cubed.
Minus 1 cubed. This would equal...
That would equal just
a positive number, so positive. So since it's positive,
the limit would be infinity. That's your limit.
Okay, kids, we've come to the last leg of our tutorial on infinite limits, and we just need to go over some properties of infinite limits. So, if you can read this kind of sloppy handwriting, let's say we have the limit as x approaches c of f of x equals infinity, and let's also say we have the limit as x approaches c of g of x, which equals L, some number. We have three things. We have the sum and difference property, whereas if we're trying to find the limit as x approaches c of f of x plus or minus g of x, and it's going to equal infinity. Now, if you think about this, what we're really adding is that we're adding infinity plus some number. And if you kind of think about that, that just equals infinity. Infinity plus 1 is just infinity. Infinity plus 2 is just infinity. And so on. The same thing, infinity minus 1 is infinity. Infinity minus 2 is also infinity. So if you have infinity and you subtract or add any number, it's still infinity. So that's our sum and difference property. Next we have our product property if we're multiplying. So let's say we're multiplying infinity, which is the limit as x approaches c of f of x, times some number, which is the limit as x approaches c of g of x. If that number is greater than 0, and so if it's like 1, 2, 3, 56, then it's just going to be infinity, because again, infinity times 2 is just infinity. But if the limit as x approaches c of g of x is less than 0, a negative number, then it'll be approaching negative infinity. For the quotients, what we have is if we have the limit of x approaches c of g of x, some number L, over the limit of as x approaches c of f of x, which is infinity, we get 0. Basically, whenever you have some number divided by infinity, you always get 0. That's kind of a common rule. So now we're going to go over to Ala'a, who will show you guys some examples of these limits in use.
The first property we're going to go over is the sum and difference property. Now, as Lakshmi said, when you have a sum and difference property problem, you can split up what's in the inside. Now, our example problem is the limit as x approaches 0 of 1 plus 1 over x cubed. So what you can do for this one is you can just write the limit as x approaches 0 of 1 plus the limit as x approaches 0 of 1 over x cubed. So now you have two different limit problems. So you can just find the answers for both parts and add them together. So the limit as x approaches 0 of 1 is 1, and the limit as x approaches 0 of 1 over x cubed is infinity. So 1 plus infinity is infinity. Now the next example problem we're going to do is going to be the quotient property. The quotient property it's the same concept basically. You have the limit as x approaches 1/2 from the left of x squared plus 1 over tangent pi x. Now again, you split it up, so you can just do the limit as x approaches 1/2 from the left of x squared plus 1, and the limit as x approaches 1/2 from the left of tangent pi x. It's the same concept. We said it's from the left, but it only gave you a left sum or a left limit. So basically what you do is you just plug in that 1/2 to the x's for both limits, and you get, for the limit as x approaches 1/2 from the left of x squared plus 1, you'll get 5/4. And the limit as x approaches 1/2 from the left of tangent pi x would be undefined. Now, when something is undefined, it would be 1 divided by 0. So to help you out, you can write 1 divided by 0 underneath there. And when you divide two fractions, you actually multiply the reciprocal of the second one. So that would be the same as 5/4 times 0, which would make the whole problem 0, the whole limit. So the second problem we're going to do deals with the quotient property. The problem is the limit as x approaches 1/2 from the left of x squared plus 1 over tangent pi x. So the same as with the sum and difference, you can just split it up and write limit as x approaches 1/2 from the left of x squared plus 1 and solve that one first, and then write limit as x approaches 1/2 from the left of tangent pi over x and solve that one, and just divide the two separate limits. So for the first one, the limit as x approaches 1/2 from the left would be 5/4 when you plug in 1/2. The limit as x approaches 1/2 from the left of tangent pi x would be -infinity. Now when you divide any number by infinity or -infinity, it would be 0. So the limit for this whole problem would be 0. Now the next property we're going to deal with is the product property. This is also similar to both the sum and difference and the quotient property. You just basically take the two things that are multiplied together and split them up and find the separate limits. So the problem we're going to do is the limit as x approaches -1/2 from the right of 3 tangent pi x. So what you would write to solve this problem is the limit as x approaches -1/2 from the right of 3 times the limit as x approaches -1/2 from the right of tangent pi x. So what you would say is the limit as x approaches -1/2 from the right of 3 is 3 times the limit as x approaches -1/2 from the right of tan pi x, which would be -infinity. So 3 times -infinity is just -infinity.
Okay guys, that concludes our tutorial on section 1.5, infinite limits. If you guys want some more practice, we will also, with this tutorial comes a practice test that has different problems like we did here, and a little bit more challenging ones as well. So this is Lakshmi and Ala'a signing off. I hope this helped.